Righto, so now we're looking at scatterplots and lines of best fit. Okay, so again, big words, but let's just unpack this. Okay, so remember we had the whole idea of correlation, where one thing affects another thing. Okay, so we're looking at there being a link between two things. Now, here's the thing though, it's predictable. It's a predictable link. Predictable, all right? So it follows a pattern. Okay, so let's have a look at that. You can actually plot the IV and the DV, the independent variable and the dependent variable, on the Cartesian plane, and it will form, if there is some kind of a link, if there is some kind of a correlation, it's going to form a pattern. Okay, so what we're looking at here is types of correlation. So we want a way to be able to describe the correlation, to describe the link. Okay, so here's 6 options which I've got here, and these are called scatterplots. Okay, so that is a scatterplot, and it's going to show you whether there is some kind of a pattern existing between the independent variable and the dependent variable. Because remember, the big idea is the independent variable is causing or impacting the dependent variable. As this changes, that changes. So what we're looking at is there some kind of a predictable way that this is happening? Okay, so let's look at this top bit here. What we've got here, all 3 of these are positive correlation. That's what they all have in common. And now, how do I know that? It's because the general twist to it, the general trend is it's climbing to the right. In other words, as you move along here, it goes up. To put it another way, as the independent variable increases, the dependent variable increases. Okay, so for instance, if we did plot the 2 points, you know, there's that one, but then that one's sort of like that. Okay, so as you go up here, this one is increasing as well. All right, now if you look at the 3 we've got here, I've deliberately drawn this to have kind of different kinds of spread. Okay, so if your dots are nice and tight, like as close as possible to a straight line, okay, then we say that that is strong correlation. Okay, if it's still, you know, basically in a band, but it's a bit more spread out, you know, the band's a bit wider, then we say it's a moderate. Okay, if the trend still is, you know, you're going up, you know, there's a basic, you know, trajectory like this, but it's a bit all over the shop, then we say there's a weak correlation. Okay, so in the test, you will need to say it's either positive or negative, which we'll get to in a second, and whether it's strong, moderate, or weak. Okay, now it's a bit subjective. Okay, I get that, but yeah, that's where we're at. So let's have a look at this bottom bit here now. This is negative. Okay, so this is a negative correlation. And you need to be able to state that, okay? And the giveaway is it's basically a downhill slope. Okay, the basic thing is going downhill, okay, not uphill like up there. All right, so here's, again, this is a strong correlation here. It's going downhill, but it's still strong because it's pretty close to being a straight line. They're close to all lining up, okay? So again, that is strong. Same concept here, it's still going downhill. You can see that there is a definite trend, but it's a bit more spread out than that one. So we'll call that moderate. This one here again, it's even more spread out, but you can still see there is a basic flow downhill like this. So we're going to call that weak. Okay, so in the test, you will need to say whether it's positive or negative, and whether it's strong, moderate, or weak. All right, let's move on. So what happens when you actually have one of these things, a proper one that is not drawn by hand with texters, but you've actually used Excel. Okay, so have a look at this. We've got maximum daily temperature and the number of workplace accidents. So independent variable, dependent variable. Well, put it this way, it's kind of like, is there a link? Is this causing this? Or another way to put it, is this influencing this or impacting this? So what they've done is they've collected data. Okay, so for instance, on this day here, when it was 14 degrees maximum daily temperature, there was one accident. Okay, so that's how this is rolling. Okay, so what we're going to do here is a line of best fit. Well, first of all, the question might say, all right, it might go, describe the correlation. All right, so clearly it's positive. Okay, I would actually, it's not strong. I would call it moderate. Okay, but again, it's a bit of an iffy thing there. Put it this way, whether you call it weak or moderate is not going to be the be all and end all for passing or failing the test. Okay, so it's definitely positive though. You'd have to get that. Positive, moderate. Okay, and actually it's linear. Okay, in other words, it's forming, you know, kind of a straight line. It's not doing a big U-curve, you know. Positive, moderate, and linear. If it was coming down like that, then you'd say negative, moderate, linear. Okay, then the second part of the question might be draw the line of best fit. All right, let's explain that. The line of best fit is a straight line that is drawn through here in such a way that it is close as possible to all the points. Okay, or another way to put it is it's the most representative line of everything. Okay, so if you kind of look at it again, it's a bit of a subjective thing. If you're looking at it from the top like that, can you see that that is kind of going through all the points? So it's going to line that down like that, and I'm going to draw that in. Okay, so if I did that in the test, I reckon that'd be good enough. Okay, it's as representative as we can get it. And the third one, I would say this: use the line of best fit to predict the accidents when it is 30 degrees Celsius. Okay, because look at this. There is no data point at 30 degrees Celsius. There's one at 28 and there's one at 31, but there's nothing at 30. So if we were going to predict, we can use this line of best fit. Okay, so this is how you do that. You basically draw up from 30. Okay, so draw up from 30 and it hits the line of best fit there. Then you go across, because we want to predict what would be the number of accidents would typically happen if it was 30 degrees, according to this data. Okay. That's where we're looking at there. So, I don't know, call it 6.5. I know you can't have half an accident, but that's what the data says. Okay. That is how you use lines of best fit. Okay, so you will be asked these three things. Describe the correlation, draw in the line of best fit, and then use that line of best fit to make a prediction. Okay. One last parting thought. This bit here, which I've just done, okay, that is called interpolation. Okay, so inter meaning within, you're making predictions inside the data. Predicting inside the data. If I was to make a prediction, say that this doesn't go past 38 degrees, if I wanted to make a prediction for 40 degrees, if I was going to extend the line, I extend this line out, and this last line here is 40 degrees, that one there, that's outside the data, so that would be extrapolation. Extra meaning outside of, okay? So that's just to increase your vocab a bit, but that's what we're doing here is interpolation, and that is going to be, well, it's considered complex, okay, in the syllabus. All right, off you go.